So the Creo RecurDyn interface extension, or CRIX as we're calling it, this really simplifies the workflow of getting data from Creo over to RecurDyn. So I'll start kind of talking about what the purpose of it is and then kind of how it works. So we've gotten feedback from customers in the past that the workflow of getting data, CAD data into RecurDyn can be a little bit tedious, and especially if you have to update components, knowing which things need to be updated, making sure everything's up to date, that can be kind of a job of its own. And if you already have dynamic models built in Creo, it would be really nice if you didn't have to recreate a lot of that work inside of RecurDyn. So Creo mechanism design uses joints that are very similar to RecurDyn. So we want to make sure that if they're in Creo, you can automatically bring them into RecurDyn. And then keeping geometry up to date, like I said, that can be a bit of a task, and the harder it is, the less likely somebody is to do it. So if it's a really easy process, then you can do it more often and be more confident that everything is up to date. So how does the whole thing work? Starting in Creo, there's an interface to export your assembly and some of the metadata that we can then bring into RecurDyn. And there's an import process in RecurDyn. So anything in bold is something that the CRIX extension is there to help you with. So between importing and then going to update it later, there's steps that anybody would take, adding in RecurDyn specific options, checking mass properties, things like that. And then running simulations. Based on that simulation, you're going to make some CAD changes, and you need to export those CAD changes and bring them back into RecurDyn. And then there might also be changes that have been made by somebody else in the organization, which you may or may not know about. So you want to make sure that changes that you weren't aware were made are getting into your model, right? So we handle the export for you and then update any existing RecurDyn components, making sure that any joints and contacts that you've already created are preserved. I think preserving contact is the most frustrating part of updating geometry in RecurDyn. So I do see a question in the chat, sorry. What versions of Creo is the interface available for? So we're supporting all of the current versions of Creo. So starting, I think that's 6, 7, and 8 are the currently active versions. And then on the RecurDyn side, we're supporting v9r4 and v9r5. So this is what the export dialog inside of Creo looks like. There's a button that launches this. This is the only set of options that you have to answer to export an assembly. It'll export all of the visible components by default, or you can selectively change that. By default, it'll export all of the available joints. If you didn't want to do that, you could turn that off. And then in v9r5, we can automatically launch v9r5, and if v9r5 is already open to a model, you can begin the import or update process automatically. Then once you get over to RecurDyn, you have a couple more decisions to make. You can modify the assembly structure. So by default, we preserve the assembly structure, mapping subassemblies into subsystems, and then recursively doing that. A lot of times you have a large subassembly that everything can be combined into a single component for MBD purposes. So that's an option where you can merge everything together, and I'll show that. Or you can keep things separate if you need to. And you can also choose to not import something for both the geometry and the joints. And the update process is really the exact same set of dialogues. So at this point, I'll jump over to the live portion. I'm going to reopen RecurDyn so I can get rid of all those. While that's coming up, we can take a look at the model that I'll be using for the demo. This is actually a tutorial model from Creo, so it has a bunch of components, makes it really easy to work with. So there's a lot of little components in here for the, like all of these pistons have 5 or 6 components in them. In reality, we probably only want to have one body for that in RecurDyn, so we'll see merging those together. And then most of these have dynamics joints, so like sliders and pins, and some cylindrical joints. So most of that work can be avoided on the RecurDyn side. So we'll start with an empty RecurDyn model for the example purposes, and then I'll switch over to a more fully built one. So there's, on the Creo side, there's only one button you have to worry about, the export to RecurDyn, fairly straightforward, and then it'll bring up this dialog that I had mentioned before. So by default, it's exporting all the visible parts, which means you can use representation views to kind of segment what you do and don't want included, or you can go and individually select or deselect them. For this, we'll just include everything. We'll include our joints, and we're going to pick off the RecurDyn import automatically. So behind the scenes, what it's doing is looping through the entire assembly, capturing some metadata that the RecurDyn tool ends up using. One of the things that it captures is the last time the geometry was changed, so that on future updates, we're only selectively updating things, anything that's changed, and we can kind of alert you to, hey, these 10 components changed, and these ones did not. So you don't have to worry about whether or not somebody else in the organization changed something that you weren't aware of. And it's also writing out all of these components as parasolid files. So what this means is you don't need any other reading libraries to continue with the export, or sorry, continue with the import on the RecurDyn side. So it's going to ask us if this is the model we want to import into. Click yes. So now we can see a structured view of our assembly. And in reality, I would go through and kind of selectively choose things. What do I want to combine? What do I don't? For example purposes, I'm just going to convert this one to a body, and we'll see what that does compared to another subsystem body. Now, under the hood, this is going through creating bodies for all of those components, inserting all of the relevant components into that body. So when I merge a subassembly into a body, it's going to create a solid for each one of those parts. And then it's going to create subsystems for all of the subassemblies that I left. And once it's done with that, it'll go through and create all of the joints that it can. And it also handles positioning. So one nice thing is you don't have to worry about the modeling units that are used in Creo versus RecurDyn. It handles any necessary conversions for you. And that's even if you change the Creo modeling units later. We can see the UI sort of updates on occasion, and we can see that it's created the subsystems. It's created one of the, well, 2 of the parts. And then pretty soon it'll go through and create all of those joints. Just about done. And then the first time you import something, it gives you log output of everything that it did. So there's sort of a barrage of information there. But then on subsequent updates, you can see more specifically what was done. So we'll quickly take a look at what entities it created. So we can see these subsystems here. I think it's this one. Yeah, this one got created as a body. So we can see all of these were all individual parts in Creo, and they were created as solids here. So we don't have to worry about any joints between them. And then we can see all the joints that it did create. So there's pin joints here, there's cylindrical joints down here, there's slider joints between some of these components. Now in reality, so just to compare the two different approaches to importing things. Now we have a subsystem with all of those components as individual bodies, so they have to be constrained separately. So in some cases you would want to do this, and in some cases you wouldn't. For this model in particular, we want all of these to be bodies, so I'm going to switch over to another file where that's already been done. So you can see this looks a little bit more like what we would want, and I can run the analysis. And we'll see that whoever made this Creo model forgot one of the constraints. So we can go back into Creo and fix that. So these all have sliders. These are sliders connecting the piston to the ground, but this one is missing that. So we'll switch over to Creo, add that joint back in, and then make a geometry change just so we can see. But first, I'm going to add contact just so we can see that the contact patch gets updated when we change the geometry. So we know what that looks like, and we'll add a hole on the top here and see what that does. This is a demo, so I already have that feature there. I'm just going to turn it on. Obviously, this isn't something that you would really do, but it's a lot more obvious than kind of a subtle change that you would actually make. And then we'll go into the piston, which is missing the constraint. So I'm going to add this slider. And then go through and export it again. And one nice thing to know is that each of these pieces operates independently. So the person exporting the Creo assembly doesn't need to have RecurDyn installed, and the RecurDyn user doesn't need to have Creo installed. It kicks out a .crix file that contains all of the necessary information, both geometry and metadata, and that can be just shared as a normal file. When we use the begin RecurDyn import, that kind of handles it for us, but that file is still created, so we could share it around the organization. So it's still looping through and just writing out all of those files again, and making sure that the update time has been updated. So we'll go ahead and update this model. We can see that there's no geometry changes that have been made. Everything's grayed out. If we had added a new part, for example, we would see another line item here that we could turn on or turn off. On the joint side, we do have that new joint that was created. So this is going to loop through each of those pistons, updating the geometry and preserving any changes that we had made to the bodies or the contacts and joints, all that stuff. Anything that the user has added, that's still going to be there after the update process. And while this is running, this is the last thing that I'm going to show. This is still in beta, so we're looking for customer feedback on what they like, what they don't like. So if you're interested in participating in that beta, you can reach out either to me or Nelson, and would be happy to help you with that. And this will take just a few more seconds. Alana, I did want to ask if there are any questions from the YouTube chat.
No, I don't have anything in the YouTube chat. Thank you for checking, though.
It's easy to forget. All the other ones just pop up for us. Okay, so we do have a question about NX. So we don't have this functionality for NX. Right now it's just for Creo, but we would love to gather feedback on kind of what other CAD systems our customers are using and look into whether that's possible. Okay. So now we can see everything has been updated. We get some log output about all these pistons being changed, and that new joint has been added. That there, and all those holes are there. And we can take a quick look at the tessellation of the contact. And we can see it does include that hole now. So much less chance for forgetting something and then finding out after you run the simulation.